Okay, so I'm just getting all connected up. If you just bear with me while we wait to check everything's working. Currently got a warning up, which is lovely, saying that my internet rate is a little bit too low at the minute. So we'll see how that goes. I know it's different for me to stream through YouTube. I'm just giving it a moment to check everything's working before we get going. You're also 25 seconds behind what I'm doing, so that's also different. What I will say is, please can you, any comments, anything you want to kind of say, please write in the chat. I'll be looking at that and answering questions as we go along. Sure, I'm watching the chat, that will be handy. If someone can just say hello so I know that that's working and I can see it, I'll be grateful. And then we'll be good to get going. Hope your other exams have been going well. It must be nice now to just be ticking them all off. And paper one tomorrow. It'll be good if we get paper one. Paper one is a little bit, we obviously we don't know what's going to be on it. It could be any of the topics. We've got the high frequency topics, but it could be anything. But once paper one's done, there's two other papers. Topics can repeat, obviously, but they don't tend to so much. So we can start then to really predict what 2 and 3 are gonna bring. It's obviously different for hi, thank you so much, Gemma. Thank you. No, it's working. That's great. You can only comment if you're a subscriber, and you've got to subscribe, and then 5 minutes later you can leave a comment. So it might be worth getting that set up now, in case you've got any questions at the end that you want to ask, sorry, that I can answer. Okay, right, let's get going then. So welcome to the night before paper one. You have absolutely got this. I hope that no one's here now panicking. Maybe there are. And the aim of this session is to kind of to answer any last minute questions that you've got, but primarily as well, just to, give you confidence and let you know that you have got this. I've been working with quite a few students, a lot of you now, for a number of years. All the preparation, this is just the final part, okay? And this is where we show off your hard work. Tonight is really about calming nerves, if there are any nerves, and easy wins. I always say it can be worse for teachers. It's bad for teachers as well. We're so wanting you to do well. But there is no point getting nervous about something because it will just drive your brain, in the wrong way. So we need to calm your nerves, easy wins. So where can we really get those marks? You have absolutely got this, but how can I help further to kind of give you any strategies that might work? This session will be around 20 minutes, leaving time for any bits at the end that anyone wants to ask, okay? Number one, and this is so important, you do not have to be perfect to do well. You do not have to look at a question, a really wordy question, and think, I can't get the final answer, right? Part marks are crucial. Say this is a 4-mark question, 3-mark question maybe. It's separated into different sections. If you can work out even part of it, you're getting the marks, okay? It's not about getting full marks, it's those part marks because they all add up, okay? So this ratio question, for example, even if you can just split something into a ratio, okay, then you'd be getting those part marks. So break every question down. Often when I'm teaching, what I like to do is literally just draw a box over bits. Okay, well, that's not a very good box, but a box that's going to cover bits up. Look, something like this, look. Okay, and drag it down bit by bit. So when you're doing it in the exam, cover up parts of the question. Just think, what is that telling me? What can I write down? Okay, just try and do something with the numbers. As you're kind of moving on, and just forget the rest of the question to kind of start with. Point 2, brain dump. Now, you're given a formula sheet, obviously. Number one, use that formula sheet. Make sure, hopefully your teachers have been through it with you. You've been using it in your mocks and you know what's there, as you're kind of doing it. But not everything is on the formula sheet. And this idea of the brain dump is when you go into the exam, write down any key formula. Okay, and we're going to go through that as well tonight as well. Okay, some of the key formula that you might want to just walk into the exam and write down. I'm focusing on foundation for this. The reason I'm focusing on foundation is because that's the majority of the students I tutor at our foundation, but some of the same principles apply to the higher paper as well, okay? Okay, so first things first, key formula knowledge. So on your paper, on your formula sheet, these are some of the key formula that you're given. Okay, they might not be given in a form necessarily, you know, that you've always been using, but they're given there, and please make sure you're looking at them. Something I do want to highlight: the volume of a prism is the area of the cross section times length. There used to be a diagram with this as well. It used to be this weird like cross section wiggly shape there, and it would go around like this, and it would remind you that that is the cross section, and you would be timesing it by that length there. They've taken away the diagram now, so but just make sure that you don't miss out on that one. It's absolutely critical. Okay, the area of the cross section times by that length is going to give you a volume of any prism. So if it's a cylinder, you know, that's a circle at the end is the cross section. You're doing the area of the circle, pi r squared, multiplied by that length. So just make sure that you're you know, aware of that, and it doesn't get lost within all the words, basically. Okay, others then that are not on there that I think are crucial, and that where students sometimes forget to do key things. The area of a triangle, please don't forget base times height divided by 2, okay? Or half base times height. However you've been using it, I'll write down that as well. Or half base times height. Don't forget the half part, okay? If you're just doing base times height, that takes us to a rectangle or a square. That would be base times height. But just to remember, for a triangle, we're actually doing half of that value. Okay, it's only the half that we want. So base times height divided by 2. Okay, next things then. Volume. I've mentioned volume. I just wanted to point out that that formula there is still there. Speed. It's not on there either. Speed equals distance divided by time. I would go straight into the exam. And when you're told to write, obviously don't write before you're told to, but just spend 1 minute getting key information straight down on that formula sheet. Sometimes you're wasting time at the end. Well, not wasting time, but you finish early. You know, let's just use your time effectively to make sure that when your brain is fresh at the start, before it's getting confused by any of the maths, you've got this information down. If you're used to using triangles, speed, distance, time. Okay, speed equals distance divided by time. Another one that I haven't put on there, but it might be worth writing this down as well. If you're used to using your, SOHCAHTOA, I better get it down before I start speaking. If you're used to using SOHCAHTOA, get that down as well. Okay, I'm reminding yourself that when they're next to each other, you're multiplying, and when they're on top of each other, you're dividing. Okay. Units of measure. That might be something else you want to get down. So reminding yourself that 100 centimeters is 1 meter. 1 kilogram is 1,000 grams. Any of those key things you might want to get down. And angle facts I'm going to go over in a minute, because I think they're a good thing to have a quick refresh of as well. Okay, so anything that you're thinking that you think, right, that's not on the formula sheet, but I keep forgetting that equation, I keep forgetting that formula, write it on it as soon as you're allowed to write in the exam. Okay. Right, I'm just having a check that everything's working properly, because I'd hate to be talking all here and we're not. I think we're fine. Lovely. I've got 24 of you, 27 of you on a minute. Perfect. Okay, right, next part then. Perimeter versus area. I now want to cover some topics that I just want to remind you of, okay? Perimeter, remember, is the length outside a shape, okay, or the distance around a shape, but perimeter is a length. It is measured in centimeters. So the perimeter of this square would be adding together this outside lengths, okay? Adding outside lengths together, called the circumference in a circle. And then the area is a space taken up inside the shape. Okay, and if you had a length of centimeters, then your units for area would be centimeters squared. Area is in a 2D shape, volume a 3D shape. So remember, volume is cubed. Okay, just want to make sure we're okay. Centimeters squared, centimeters cubed for that one. Okay, key skills you can do, but they're sometimes forgotten. Okay, they're missed off. I've made a few series of videos recently on TikTok on these, just because they're the topics that are sometimes forgotten. And substitution is one of them when we're dealing with 2x squared versus 2x squared. They sound the same, don't they? But they're written differently. And this relates to bid maths, actually. Maybe I should be doing bid maths first. But the point is, the first one, just change color. This first one, let's say x is 3. The first one, we have to do the x squared first. It is bid maths. We have to do the indices before the multiplication. So that is the same as 2 times 3 squared, which is 2 times 9, which would be 18. Whereas 2x in brackets being squared, you'd need to make sure you're doing the 2x first. So that would be 2 multiplied by x is 3, 2 multiplied by 3, and then squaring it. 2 multiplied by 3 is 6, and 6 squared is 36. Okay, so just remembering the difference between those. Moving us on to bid maths. Okay, apply bid maths. I actually had a lovely question. I don't know if Izzy's on the lesson now, but she sent me over a question earlier, which was a bid maths question, which would be quite nice to go over now. Just have a look at it together. So the question is, I'm writing it up here. The square root of 100 subtract 4 bracket 2 squared plus 5, 4 bracket 2 squared plus 5. This is a non-calculator bid maths question. So let's have a review of this one together. I'm just going to pause and see if anyone wants to have a go on your own to start with. And I will be with you. Give it a go and see what answer you would get. Okay, right, let's have a look then. So brackets and bid maths, we always have to start with the brackets. So you would start by doing the 2 squared plus 5. Okay, and within the brackets, there's an indices, so we're going to do that first as well. So inside the brackets, 2 squared is 4, 4 plus 5 is 9. Okay, so we've got 9 there. 4 outside minus, filling in the rest of it, okay? Right, what's next then? So indices, there's no more left. There's a multiplication here. When it's in brackets outside of it, we're doing 4 times by 9. So we've now got 100 multiplied by 4 times 9, which is 36. Okay, so division and multiplication at equal levels. You do those from left to right. And then your addition and subtraction. So we can go on to do the rest. We're doing 100 take away 36, which is 64. And the square root of 64 is 8. Okay, so a lovely example of a bid maths question. Thanks, Izzy, for that. Where you can kind of see it in practice on the non-calculator way. Okay, collecting like terms. Something else, just something else that's worth mentioning. X and x squared, apologies, are not like terms. If I had 4x plus 2x, yes, that makes 6x. But 4x plus 2x squared, you cannot simplify that any further. So please do not collect x's with x squareds. Right, let's keep going and see. Oh, here we go as well. Parts of a circle. I do not want tonight to be about me just giving you loads of information. So apologies if you feel like that, but I just want to highlight the key things to remember. Okay, so I hope that's okay. Right, parts of a circle. Now let's make sure we can label them. So we have the diameter there going straight across the middle. And we have the radius. So the diameter goes from edge to edge. It has to go through the center. And then we have the radius that goes from the center to the circumference, the center to the circumference, okay? We then have a chord. Now a chord crosses the circle again, going circumference to circumference, edge to edge, but does not go through the middle. We have a tangent. And a tangent is it touches the circle. And if we draw a radius We draw it a proper line. If we draw a radius from the center of the circle to where it touches, that always meets at 90 degrees. Okay, so there's a 90-degree angle there. And finally, there's the circumference. The circumference goes all the way around the outside of the circle, essentially the perimeter, but for a circle, okay? Right, now's a really good time with 5 minutes to go. The settings on my video are set so that only subscribers can comment. If you want to comment at the end, if you want to ask any questions, now would be a good time to hit that subscribe button. So you've then got time to do it at the end, okay? You've then got time for it to allow you to answer those questions. Okay, another question. Will the examiner mark my diagrams? It's quite often you've got a question come up and you've got the diagrams with the sometimes you've got lines, sometimes you haven't got lines depending on your exam board. Your examiner, when it's marked, what happens is we get through a question at a time normally, and you can opt to see more of that screen if you'd like to, and we do check diagrams. They're completely checked, okay, and it is allowed to mark angles on the diagram, mark any of your bits on the diagram. If the question says give a reason for your answer, maybe that would be a good place to put the lines, to put it on the lines, okay? So this question, for example, I might be looking at it thinking it's not a one-step question. If I've got this angle here that's 50 degrees, I could fill in that angle there is corresponding. That would also be 50 degrees. And then I'd be using the angles on a straight line, add up to 180, and I'd be showing my working of 180, subtract 50 to give me 130 degrees. Okay, making sure I stated the rules if it asks you to, but yeah, completely mark your diagram. Please do. Makes it clearer as well sometimes. Okay, right, let's have a look what else we want to kind of cover. Oh, I've kind of put quite a bit here. I don't want to do too much content, but let's just stick with these easy wins. Index laws, right? Remember, if you've got something like a cubed multiplied by a squared, we add the powers. So that's a to the 3 plus 2, which is a to the 5. So remember to add those, okay? Right, the next one, when you're dividing them, a cubed divided by a squared, we're subtracting the powers. So a to the 3 take away 2, which would be a to the 1 or just a. So the first one, multiplication, we're adding, division, we're subtracting. Next, power of a power, and I'm going to use a different example for this. So if I have something like 2x squared cubed, right, I'm not asking you the easiest questions here because this is forgotten. People are quite used to saying that's x to the 6. They do the 2 times 3, x to the 6. But what students are forgetting sometimes is that the 3 also needs cubing. So my answer would be 2 cubed x to the 6. Okay, and we could then simplify 2 cubed, 2 times 2 times 2, which is 8. So 8x to the power 6 there. Okay, so don't forget that one. I'm not going over negative and fractional because I'm trying to focus this on the foundation. I know it can come up, but I want to keep it nice, simple, and not too confusing. Okay, there is a TikTok video on that was uploaded a couple of days ago. I think it was on all the platforms actually. Multiplying decimals, easy win. Make sure you are counting the number of digits behind the decimal point in the question, and it should be the same as in the answer. So if I'm doing 0.8 multiplied by 0.03, for example, ignore the decimals, just do 8 times 3. 8 times 3 is 24. Now, this is where we count how many digits are behind the decimal point in the question. 1, 2, 3. And there needs to be 3 after the decimal point in the answer. So I'd need another 0 in front of that there. And then I've got 1, 2, 3. So a quick check, okay? Check that you've got the same number of digits behind the decimal point in the question as you have in the answer. Fraction of an amount. 2/5 of 50. We're dividing by the numerator. So 50 divided by 5, which is 10. And then we're multiplying by the numerator. Okay, divide by the denominator, multiply by the numerator. 50 divided by 5 is 10. 10 times 2 is 20. Okay. Okay, thank you so much. I've got my first question in the chat, which is lovely, and I'll do that at the end. So exact trig values we'll completely look at. It tends to be a 1 marker for foundation, just state a value. I know in higher it's used a little bit more, but I'll review that at the end. Exact trig values. Angle, key rules. Okay, don't forget, sorry, remember this is something you can put on your formula sheet as you go in. Angles in a triangle add up to 180 degrees. Angles in a quadrilateral or four-sided shape add up to 360 degrees. Okay, triangle 180, four-sided shape, quadrilateral 360, and we're adding on 180 each time. But pentagon, five-sided shape, add on another 180 to 360. Okay, and it just keeps going up like that. Right, your formula, let's say it anyway. The formula for what the angles add up to in any polygon, the number of sides, take away 2, and we times it by 180. So that's your formula for the sum of angles, interior angles in a polygon. So for that four-sided shape, the quadrilateral, 4 take away 2 is 2. 2 times 180 is 360. So you just substitute the number of sides with the n. Okay, angles around a point add up to 360. Okay, angles around a point add up to 360. Angles on a straight line add up to 180 degrees. And then vertically opposite angles are equal. If this angle here was 110 degrees, that would also be 110 degrees. And we could work out the missing angle using angles on a straight line. 110, that would be 70 degrees. And this here would be 70 degrees, okay? So using different rules, different combinations of rules to kind of get to where you need to. Okay, so 180, 360 are your key ones. Well, 3's gone a little bit there, hasn't it? And then vertically opposite angles are equal. How are we doing for time? 20 past. Just having a check where we're at with everything's working. Perfect, we're all good. Okay. Averages then, your mean, median, mode, right? Median in the middle. So you've even got a D in the right place for you. Middle when in order. Mode, most. That's got 2 letters in the right place for you, look. M-O, mode, most. Mean, add them up and divide them by how many there are. So add together. Divide by your number of pieces of data. Now, it's very different to the range. Don't get confused between the two. The averages is an average of the data. Okay, it's expected to be within the data. The range is not an average. The range is a measure of the spread or the consistency of the data, measure of consistency. And to do that, we do the highest take away the lowest. Oops. Okay, so just be clear that they're your averages. The range is a measure of consistency, okay? Okay, right. I wasn't necessarily planning on going over content from my end because it's a bit like, you know, people might have specific questions as you have in the chat. That's great, and I'll go over that. But let's just look at a few more strategies to to give you any last minute advice I've kind of got. And the first one is the time management. I teach a lot of students, and there are certain students who use the whole time. Okay, they use the whole time and they struggle to finish, and that's fine. That's fine. You've got your time, you know, that you kind of need. But please do not get stuck on a question, right? Don't get to the point where you're spending 10, 15 minutes, you know, you've got pages of working all over the place, because go on to something different. Unless you're at the end of the paper, by all means, you know, unless you've done it, you've checked your work, by all means do it. But please use your time effectively. Working out is crucial. There's so many method marks, and even if you've then made a wrong calculation at some point, if you've then showed the method for the next part, you can gain a method mark. we always say it to you as teachers, and I know it's frustrating for students because everybody says it, but please, if there's any time you're going to show you're working out anything that's going through your brain, similarly when it's the calculator paper, anything you're typing into your calculator, just get that working out down. Crossing out. Okay, there's nothing more frustrating, although I'm sure there is, but it's extremely frustrating when students have crossed out a load of work, like completely scribbled it out so we can't see it, and replaced it with nothing. It's absolutely blank next to it. There might be something in there that we can use. Just today, I could just think when I was teaching today, I had a student that completely crossed something out because they thought that they got it wrong. And I went over to help us and she got it. It was all right. It was all absolutely perfect. And it's just, if you've got something, if you really think it's wrong and you've got something to replace it with, by all means, do that. Okay, by all means, cross it out and make it clear how which answer you want the examiner to mark. But if you've got nothing to replace it with, leave it. Okay. And on that note as well, put something on every question. Ask yourself a mental checklist as well. Okay, what is the question really asking? Have you shown your method, and does my answer make sense? If you're getting an answer for an average that's not within your data, okay, you've gone wrong somewhere. If you've got a straight line graph, right, y equals mx plus c, a straight line graph equation, and it isn't making a straight line, you've got these points that are absolutely perfect, and then one down here, right? Think, I've gone wrong somewhere. Let's correct that point, okay? So just check it makes sense. So remember your brain dump. If you are in panic mode at the minute, you can and you will do better than you're currently thinking. Okay, if you're not in panic mode and you're feeling positive, you're feeling good, we're all fine. But if you are in panic mode, you can and will do better than you're currently thinking. A calm brain works better than a tired one. There's nothing worse when you're angry and someone says, "Oh, calm down." You know, I know it doesn't work like that, but make sure you're just rest as much as you can. Trust your preparation. Okay, trust yourself in the kind of amount of preparation that you've done so far. That's the part that matters. Don't now cram if you are in panic mode. Okay, you know how you work best. You're old enough now, you've done your mocks, etc. But I wouldn't go into, if you're in panic mode, don't overly panic and do more, just relax. Okay, I've got one question in the chat. How do you work out a question like what is the exact value of sine 30? So I'm now just going to go over my method for exact trig values. It's a 1 mark question on foundation, more marks if you're doing the higher paper. I go between different methods when I'm teaching this. If I'm teaching it online, I'd use the table method. And if I'm teaching it in class, I tend to use the hand method because I find it easier to kind of show students. But let's teach you the table method for tonight because that's where we're online. So first of all, you have to know the exact values that you need to know. So we've got sine, cosine, and tan. And the angles we need to know are 0 degrees, so sine, cos, and tan of 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay. So this is my hack. What we do is we start by writing out 0 to 4 on the sine. Okay, 0, 1, 2, 3, 4. And we divide them all by 2. And we square root just the numerator. And that's it. So 0, 1, 2, 3, 4 square rooted, all divided by 2. Okay, and that gives you, that is the exact trig values for, so sine 30, I think your question is on the chat. Well, sine 30 is root 1 over 2. Now that can be simplified. What is the square root of 1? The square root of 1 is 1, so it's a half. And the others can be simplified. Square root of 2, okay, over 2, that can't, sorry, root 3 over 2 can't. Root 4 over 2 can. The square root of 4 is 2. And 2 over 2 is equal to 1. So that's just 1. And that one is 0. Right, and then when you're doing cosine, so that's sine, 0, 1, 2, 3, 4. Cosine is 4, 3, 2, 1, 0. We go backwards. But we can just use our simplified version already. So cos of 0 is the same as sine of 90. So that's 1. Cos of 30 is the same as sine of 60. So I'm working in reverse here. Root 3 over 2, root 2 over 2, a half, and 0. Okay, so that works backwards. And then tan. Root of 0, root of 1, 2, 3, 4 again. They're all square roots, sorry. So 0, 1, 2, 3, 4, just like sine, but we divide it by 4, 3, 2, 1, 0, square rooted. And that's that really. That is all you have to do. That's just a table to kind of remember, perfect thing to get down on the formula sheet as you walk in. Once again, these can be simplified. So the square root of 0 is nothing, and nothing divided by 4 is still nothing. This one, you can't divide by 0. If you even tried to put that into your calculator, it would come up as an error. And that's because of the shape of the tan curve. So that's nothing as well. The square roots of 1 are just 1. So that's just root 3. Square root of 1 is 1. Oh, this one as well. Look, square root of 2 divided by the square root of 2 is just 1. Okay. So that's all the values there. Yeah, so yeah, simplifying them, I'd encourage you to simplify them, but they're nice simplifications, you know, they're quite kind of easy ones to do. But yeah, I would recommend you simplify them. Okay, are there any more questions? Thanks so much, Gemma, for typing in the chat. Right, just let me know how it goes, please. Everyone that I teach, I'll obviously see tomorrow, but everyone that I tutor, please just make sure you let me know how you kind of do. Best of luck, and I will speak to you after. I'll see you on the other side. And just any last minute questions, I've got a few students I need to respond to tonight now. I'm here. I'll be working until 10 easily. So just send your questions in. You know, you've got my number if you need to contact me. Okay. Right. Thank you so much for coming along. And I'm hopefully the technology worked okay. And I will see you for the next one. There'll be one for paper 2 next. Okay. Bye-bye then. Have a good evening.